Okay, welcome back to the Earth Science Classroom. This is a series of videos looking at the Earth's interior and discussing what's going to be included in those videos so you can peruse to your liking. So basically, our planet, our beautiful third rock from the sun, is the third rock. So it is pretty much rock. Now, obviously, on the surface, we have a split of 70% is mostly ocean, and then we've got 30% land. But beneath the ocean, there is solid rock in a ocean floor, seabed, and then below that into mostly sedimentary rock, and then down into the mixture of igneous and metamorphic rock that makes up our crust, the silicate minerals and silicate rocks, and then down further. So these videos are going to look at what is beneath our feet, how far, how deep do we go to get certain compositions, certain characteristics, certain layers of the Earth. And basically, in Earth science, this is like, for me personally, this is my starting point. When I finish rocks and minerals and the rock cycle, I go into the Earth's interior and I kind of give them a project and I kind of give them a research project to look at these different layers and experience and show how different they are and where they are inside the Earth, because we do a lot of work on the surface processes, the morphology, the history, even the tectonics is all based on the surface features and movement. And what we don't spend enough time on really is the Earth's interior, because it is one of those things that is a lot of best guess scenarios, scientific calculations based on surface experiments and applied to an interior Earth that we haven't been. And we have really only drilled down about 7 miles underground with a 2-inch drill bit. And that was in the Kola Deep Hole expedition, basically in Russia. And they had to stop because the heat that was experienced down there by the drill was actually making the drill malfunctions. They couldn't actually go deeper. And basically, the physics, the chemistry, and also the math that is associated with Earth science really comes into play a lot in the Earth's interior, and the foundational chemistry and physics and math that we can apply is good for each student, because then they get a well-rounded scientific viewpoint on the Earth's interior and not just looking at the composition perhaps and how and why these things happen inside the Earth and how we get a liquid outer core, or why there is a low velocity zone in the top part of the asthenosphere, and why this happens and how it happens in terms of physics and chemistry. So, and obviously, as you go up into the higher levels of earth science and geoscience, you'd obviously increase the levels of physics and chemistry you would be discussing. But in these videos, we're going to bring you through each layer. We're going to talk about the layers, talk about the composition, the structure of our Earth, our planet. And in particular, we're going to look at the outer core as a case study with the EM field. We're going to look at the inner core in terms of the metallic composition and in relation to Earth's history. We're going to look at the asthenosphere in detail and also discuss convection currents. So as I mentioned earlier, I start with the Earth's interior because then it gives the student the appreciation of the layers, and then it can go into more detail about the upper mantle and the lithosphere and the crust and the two differences between the two crusts, ocean and continental, and really discuss the convection currents, how they affect the crust and produce things like continental drift theory with Pangaea and Wegener, and moving into seafloor spreading with Hess and other scientists, and then looking into the idea, the concept of plate tectonics that came really about in the 60s and 70s. So these is very important to kind of demonstrate to the students the importance of understanding the Earth's interior and how it leads to fully understand or better understanding the processes that happen on the surface.